Hi, sweetie. So I just am going to try to show you what it is that I mostly try to do um, to help kids understand what you need them to understand. I'm going to just use really some basic things here. So I'm just going to put in a couple of points. 0. Oops. So let's go 0, 0. And we'll go with, like, I don't know, 1. No, let's go with 3, 6. Okay. Actually, no, sorry. Let's go with 9, 12. Okay. So here we have, oops, I meant to put in a 1. Oh my gosh. I'm sorry. My 1 button has been sticky lately. So 9, 12. Okay. So we can't quite see it, but there it is. Okay. So now the idea is that you could ask a kid, you want to describe the slope of a line. But before you do that, you start with just getting the idea of talking about moving from one point to another. How do I get from A to B, right? So then the kids, they kind of figure out, okay, well, I mean, if you're talking about a math discussion, and it depends on how much time you have, clearly, right? But they're like, okay, if I need to get from here to there, how would I make sure I get there? And it's really hard to talk about a diagonal. We'll go diagonal and how many squares and how long and when do I know? So pretty quick, they should figure out, well, just go so many to the left and then so many to the right, to get from A to B. So then what we talk about is say, yeah, really from any points, A and B, right? There's always some kind of a horizontal distance you can travel that's really easy to define, right? And I call it delta X. Your kids might not be ready to discuss that, but if they use the word horizontal, right, you can say it's horizontal change, right? That's pretty easy to think about, this idea of horizontal change, right? And then over here, you have what's called vertical change. Okay, I'm pretty sure they'll know what vertical is, right? So vertical change, right? And so the idea is to go from one point to another, we just simply describe it as horizontal change and vertical change, right? Now, you could do the horizontal first and then the vertical, or you could go the other direction. Let me get another color here. I don't know. Let's try this. You could go this way. Some kids will come up and say, well, I went up 12 and then over 9, right? Does it really matter? The answer is no, it doesn't matter. You're still doing the same thing. But if I were to ask you to describe it in a way that somebody in Russia or a Chinese person might understand it, it turns out that we can't use English to describe that. We have to come up with a more consistent way. So the mathematicians that kind of first did this were the French, right? So the French said, let's call this, like, this direction between one point and another. Let's call it M, and it was literally, they're using that for the slope of a mountain, right? Mountain, right? So montagne, I don't know. I don't even want to try to pronounce it in French, but it's the French word for mountain, which, for us in English, we think of the slope of a mountain, right? So we call M, this letter M, we call it slope. The French call it mountain, or it came from the concept of a mountain. So anyway, that's describing this direction that the line goes in. For me, since we use the letter M, I try to say, hey, look, man, think about it like this. M stands for moves. It describes how to move from one direction from one point to another. So M is the key, right? M is the key. It tells us how to move. And then what we have to all agree is, how should we write M, this description of how things move? And what we decided was, we said, you know what, let's put the vertical change on top of the horizontal change, and we could write it as a single number, right? A single value or ratio, right? So we would put our vertical change on top of the horizontal change, right? That, if we all agreed, then that would work. So the kids kind of, now, once they say, okay, they know they need to go, in this case, right, we're going up 12, right? Up 12 over 9, and that's my slope. And you say, oh, really good. That's great. That's great. So then, is there another way we could describe it? Well, somebody says, hey, wait a minute. You know what? I told the guy to go over 4 or over 3 and up 4, then go over 3 more and up 4 again, and then go over 3 more and go up 4. And you say, wow, that's over 3, but you went up 4 over 3, and then you just did that 3 times, right? You just repeated that. So now we see how, hey, 4 over 3 is the same rate as 12 over 9, just repeated 12 or 3 times, right? So now, since I can do that, right, I can actually show, and I always use these, I call them slope triangles. This idea, this slope triangle, it describes how anything moves from one point to another. The slope triangle helps us do it. And as long as we remember that we put the vertical on top of the horizontal, right? So the vertical, so if you wanted to, let me get a clean sheet of this. Let me close that out. And let's try this again real quick, okay? So what I'm going to do if I had a line is I'm going to think, like, let me go up over here from one point to the other. I have a fraction. I go up 12 over 9, right? Or if I want to go this way, I also have a fraction, right? I can say I went up 12 over 9. Just by connecting those, I can show 12 over 9. Okay, and then think about reducing it. Can I make them smaller? Well, once you start going, hey man, this is over 3 up 4, right? Guess what? That ratio, 4 over 3, that holds true for any points on the line, right? So now this is the ratio, M, which tells how that line moves, right? So first, you're talking about how much time and how far do you want to get with kids, but I would want them to understand if I have to describe how a line moves, I can pick any 2 points. I can make a right triangle with it. I can describe the vertical change on top of the horizontal change as how that line moves. And in my tests and in the textbook and in math class, they're going to call that slope. But it means more to me. It means how this pattern of dots aligned in a row is moving from one to another to another. It's moving in this way, okay? And actually, if you have time, you can actually, oh boy, let me close that out. And let's see, you can, if you get a chance and you use GeoGebra, I hope you ever do if you ever get a chance to. If we were to draw the line that connects these guys right here, then you can kind of show it to them. Hey, check this out. There's the line, and it doesn't show the properties of that anymore. Oh, this is okay. Well, all right. They've changed it a little bit. I don't know if this is going to let me even do. I have to find another one of these because they have changed this a lot. Let me go back to, watch this, check this out. I'm going to go to GeoGebra, leave this. There's another GeoGebra app, not the, I'm going to go to the regular, there we go. This thing's better because it allows me to, hey, wait a minute. That's not what I want. I want a regular graphing calculator. Oh, let me go to GeoGebra Classic. That's really good. GeoGebra Classic is perfect. Okay. So if I were to put those points in again, let me put them in here. So I'm going to go 0, 0, and then what do we say? 9, 12, right? And so, oops. See that sticky one? 9, 12, right? And zoom it out so I can see those 2 points. Then use my line tool to connect them, right? And then over here I have a tool for measuring it. All right, so, sorry, I'm going to measure. This is my measurement right here, and there's my slope. You can see when I click on it that there's the slope triangle, 1.33, which is 4 over 3, 4/3, 4 over 3, okay? And then what I notice is it's written here, this line's equation is written here. If I put it in slope-intercept form, I can see it's y equals 133x. If you get a chance, you can kind of demonstrate it. You can ask the kids, what's happening to the slope, right? And then have them take a look. What's happening to the slope there? Well, what's happening to the slope is that slope triangle's getting flatter, right? It's going over 1, but only up 4/10 or less than a half, right? Or it's getting steeper. Now it goes, over 1 and up 2.39. So 2.39 over 1. Or if I went, for example, over 100, it'd go up 239. Well, look at the equation right here. So this equation tells me this part of the equation right here, we call M, tells me how the line moves. So if you get a chance to, first of all, get them just to describe, the change between 2 points, that'd be really good. And then if you can, see if I can get this to work here real quick. Let me see. Do I get no, I don't remember where those buttons are on this thing anymore. Doesn't matter. I'll do this real quick. So now if I do this right, what I'm going to do is I'm going to say, okay, this vertical change, right? This vertical change, it's the difference between this y and that y. So this is y minus y. That's my vertical change between this y here and this y here, right? And this right here is my horizontal change, right, between here and here. So that's x minus x. So another way to describe the slope is to say it's y minus y over x minus x, or the slope formula, they call it y minus y over x minus x. Now, it doesn't matter if you use this y first or that one. You have to be careful because when lines, let's close this out, when lines get a negative slope, let's give it a negative slope here, right? Negative slopes are, think of them going downhill, right? So then what we would do is say we're going down, and then, oops, went too far down here. So this is a negative rise. So the delta y, right, the vertical change is negative, right? There's some negative when I take this y minus that y. Now, some people get really concerned in books. They'll say y2 minus y1 and then over x2 minus x1. All it really means is if you start with this point, you got to do the same thing. Start with this point, and you describe it going from this point to that one. Use, this might be x2 or y2. This would be x1, y1. So if you're starting with this one right here, you got to keep the same x and y on top of each other. Okay, and then this other point, this is a single point. You can't do like y2 minus y1 over x1 minus x2. You'll start getting goofy. Okay, and then the last thing I'm going to be really careful about here, I want to just show you in case you pick 2 points or you have some kids pick some points, depending on how much time you have for them, right? And they happen to be negative and you're practicing with this stuff, right? So you're gonna kind of draw how these guys go out. So I just draw this down. They're counting down. Okay, this is from 6 minus, I don't know, like 1. So this is down 5, and then this is from like negative 4 to 3.5. So that's 7.5. So that's kind of tricky, right? 7.5. That's not a really good fraction, right? That's not a great fraction. So we would get this to become a better fraction. And one of the ways to do that would be for me to look at picking different points to work with here. Let me get a point that would be more precise, like this. Okay, and now I can just see this is 4, this is over 6, and this is down 4. So down 4 over 6. So the slope is negative 2 over 3, which is negative 2/3. You can see it right there. Okay. All right. Now that's me doing all the talking. When you have the kids, you're gonna how much time you have with them, but you might need to let them do a little bit more talking than I'm doing right now, or exploring or describing, and giving them different opportunities. Use your regular pedagogy there to figure out for the kids what's best. The slope thing is really cool for them to see, and if you want, this is called GeoGebra. You can go to use this site, right? So you can see all those tools and maybe practice it a little bit before. GeoGebra.org/classic, right, for the easiest one. And then these menus, you just click on this button, that's the point menu, and you can put 2 points wherever you want, or you can just type them in like I did here, right? Or you can just get a big screen like this up on your screen, your projector. If you have a smart board or it's on a whiteboard, and use whiteboard markers and just mark a couple of points. Have them go, whatever it is you're using. But it's nice to see this at geogebra.org because I can adjust it, the slopes changing, and the formulas right here, so they see all three things. I wouldn't lead with this. This is where I'd go once they clearly understand what slope is. I'm guessing that tomorrow, I don't know how long your class periods are, but I'm assuming that you've got not a lot of time for this. So the objective may be just to have the kids understand what slope is and perhaps get to its formula, in which case you don't have to get all the way to describing a pattern. But if you keep going, remember that the next step here is make sure they tie this back to that this is a pattern. Really, I want my kids to understand this just describes a pattern, right? This part tells me how it moves, right, for each X, right? And this part right here tells me where to begin on the y-axis. So then if I start here and I'm going, let's say right here, I would describe this line. Right, that line right there has a slope triangle. This is up 6 over 2, so it moves up 3. 6 divided by 2 is 3 each time, beginning at -6. So there's my equation right there. M, how it moves for each X, and where does it begin at -6 on the y-axis, right? This is where it begins, on the y-axis. Okay, I love you, babe. I'm gonna upload this, and I'll send you the link, and I'll give you a call and let you know it's there. Okay.